Hey, we're going to be talking about deployment and automation, and honestly, like lots of buzzwords in this title.
All the buzzwords.
Yeah, we did that. So I'm Fletcher Nicol. I'm a software engineer at Blue Box out of Seattle. So while my name's on here on this talk, I'm hoping to actually not do a whole lot of talking because there's an amazing panel down here that can talk much more at length about these things than I can. So I thought what I'd do is just kind of go down the row and have each panelist introduce themselves, because they can do that far better than I can, I think.
Great, thanks. I'm Matthew Coker. I'm a developer at Pivotal Labs. I've been working on Cloud Foundry now.
You work at Pivotal now.
I work at Pivotal Labs. We're a division of Pivotal now. It's very confusing, frankly, but just call it Pivotal and we're fine. We are now carrying forward the development of Cloud Foundry, which is an open source platform as a service, and I'm leading the engineering effort there. So we're actually putting a huge amount of engineering resources behind it to make it the deployment platform that anyone uses for deploying apps.
My name is Dr. Nick. I used to be VP of Engineering and Technology at Engine Yard, now doing consultancy around Cloud Foundry, so I am in charge of harassing Matt, pretty much. It's an awesome job, and have a lot of fun, not really when we're actually harassing each other, because I lose every time. So really looking forward to winning a couple of points.
Not actually true.
I look forward to winning a couple of points today in front of an audience, so we keep track of it. There was no end to that. I'll just keep talking. So anyway, yesterday,
My name's James Casey. I'm a development lead at OpsCode, where I work on Chef, mostly on the back-end servers. Before that, I worked at Bank Simple here in Portland, deploying an online bank with Ruby, JRuby, Scala, Java into EC2.
My name is Andy Camp, and I'm a development manager at King of the Web, which is an
That is
online...
an awesome name. That's like one better than Webmaster.
Which is a startup centered around online video, where we give a cash prize whoever gets the most votes, but centered around independent web video creators. Before that, I was at Hark.com, which is a site centered around audio, and I started at Hark with hardware on rented rack space, and I've deployed on raw EC2, Engine Yard, Blue Box, and personal sites on DreamHost, so a variety of different deployment strategies.
My name is Eric Lindvall. I'm co-founder of Papertrail. We help you see what's going on in your server and application logs and help do something about it. I don't have anything else to say, so there you go.
So I think what we were trying to do is get sort of a mix of people involved with businesses that were deploying their business, as well as some more like platform and tool makers and that kind of thing, and sort of see where things are good, where things are not so good. The best case scenario is everybody's business gets bigger and better, but then all these complications and complexities start.
Let's talk about automating failing businesses.
There we go. Yeah.
Anyone got a failing business they want to admit to? Well, let's talk about that.
So I guess I'm just curious to see sort of what everybody's, into these days, for lack of a better word, around sort of solving this problem, at least for themselves. So I guess speaking for myself from Blue Box, as a hosting provider, we get to see lots of different customers and different ways that they kind of do deployment. We're also sort of a hybrid model of virtualized resources and bare metal servers. So we have this additional bonus and challenge of sometimes helping customers provision their application on what is traditionally resources you could provision over API, and then these crazy servers, like real actual servers. And that can be kind of a challenge as you grow your business and you get more of these crazy real servers. What I would like to do is put APIs around that and just treat that hardware like software. So we've been kind of looking into how we make our lives better internally on our platform, as well as extending that out to customers in a way that, if you sort of know the needs of your application, you just sort of want to check boxes or make API calls saying, I want 6 of these and 4 of those. What's actually underneath it, it would be really nice if that was much more just opaque and a checkbox. The reality is it's a very hard thing to do when you're sort of doing one or the other. You can kind of specialize, but that's me.
Cool. I think I'd sort of echo the sentiment that what developers really want is APIs around things that they're going to have to interact with. So I think over the last few years, Heroku has really proven, at least to a lot of people, certainly in the Ruby community, that a pass can actually solve these needs of how they're going to deploy their application for the vast majority of them. And unfortunately, we've also learned that US East isn't a great place to host your application.
Why, Matt? It's where everyone else is. It's obviously awesome.
It's where the cloud is, I know. And obviously, Heroku's doing work around being in multiple availability or multiple regions. But
I love how at their first place, like, we're not just going to go outside of Virginia. We're going to get the hell out of this continent.
That's right. Go into Europe. And so I think that what that's shown is that's really the interface that developers want. Is basically, here's my code. Here's the resources it needs. It needs a database. It needs a message bus. It needs 10 instances of it that can serve n requests per minute. And sort of they want to specify that and just give that to the system and have it run it. And so we at Pivotal came across Cloud Foundry and really saw it as the thing that would allow us to do that for customers that weren't happy with being in Amazon. They weren't happy with having a closed source solution to that. And so the sort of where Fletcher's working on sort of these lower level APIs that are give me a load balancer, give me an instance. We're working on much higher level APIs of here's an application, here's the code, run it 100 times on different servers and distribute the load equally. And so I think it's really the same issue, but we're sort of attacking different levels of it.
I work full time. My customer is a large enterprise company who is in the music business, and big investment at the moment in redoing how we do IT, and Cloud Foundry is a large chunk of that. But so there's kind of that part of Cloud Foundry, which is, why does an IT group stand up Cloud Foundry? Because they don't want to hear from app developers. Just do it yourself. No. So there's part of it is providing the automation as a service. But nonetheless, we then put Jenkins on top of that. So we try to both in a purely automated sense. So when CI gets run, when you can run CI, it will deploy the app into a Cloud Foundry environment for the purpose of testing. Then it will run Selenium against that. With that same mechanism in place, we can move apps from environment to environment as they sort of go through from development to QA through integration testing, staging, and production. Which, if you've sort of come from the more agile sense or modern, if you've worked in a smaller place, well, you probably couldn't even be bothered having that many. It's like, just keep changing production until customers complain. Larger organizations have done that already and decided, no, let's not ever change production. We'll just keep failing in staging instead. No. But we have all the automation around that. So that's one level of automation. The other automation we have to worry about, which we're not that good at, but why we're pretty excited about the Bosch stuff that's coming through, is the automation of upgrading Cloud Foundry itself. It's all very nice to have nice ways to deploy your apps, but what about all the changing? The infrastructure under the app itself doesn't change as fast as the app, but still, eventually, you're going to want to get off MySQL 5.0, hopefully. Ruby 1.8.6, the gold standard, and these sorts of things. So you still want to be able to do staging production of entire environment changes. So yeah, the Bosch stuff that the Cloud Foundry group came up with is certainly something we're interested in.
I mean, I think the first thing for me as the configuration management person, is to say that you all should use configuration management.
Whatever your problem is.
Exactly.
Right?
And I really
Troubles at home. Configuration management. Children, configuration management.
And it doesn't really matter what you do, but like what we're talking about here is really agility. We're talking about business agility. We're talking about the situation where your company's growing fast. And what you want to be able to do is react quickly to that. And some of those reactions you have to do might be very small. It might be an app upgrade. It might be, as Nick said, I need to get off MySQL. I need to change out. I need to use a completely different infrastructure underneath. And the real key for configuration management, and I guess how we always put it, is infrastructure as code. We're all developers, we're all engineers. If we treat our infrastructure, it's sort of a level past, we want APIs. We want our infrastructure to be code.
Which is really cool, because then you can test it in one place and rerun that same infrastructure. It's imagine just, anyway.
So I mean, how do I construct, for me, one of the really interesting things about cloud, about AWS was having, networking as code. And, that's a big shift for a system administrator to say.
AWS networking as code. Very slow code.
Very slow code, but the fact that you can provision a second network interface as code without touching hardware, it means that comes into the realms of developers. So imagine putting all of your infrastructure into that realm where you can change it. And you can spin it up, you can build your Jenkins cloud, you can spin it up, you can test it, and you can see what happens. And it means you can start to experiment with your infrastructure just the way you experiment with your code.
And you can bring it back to the realm of developers.
Right, exactly.
As opposed to these magical people with beards.
And sometimes they become developers as well.
The meat cloud.
So from a customer standpoint, for someone using it, one thing that has worked really well for us at King of the Web, we had the challenge of we're a contest that gives away cash prizes, and from the beginning we wanted to have a public vote count that people could see, and we'd know the winner the minute it was over. And we were giving away the prize for what people voted on for the best content. And then we found that content didn't actually win, but personalities did. And these personalities are people on YouTube who have enormous social power, and they'd make a video, they'd do a tweet, and they'd deliver 10 to 50 times our baseline traffic in about 15 minutes.
Was that cheating?
No. And we would also detect cheating. People would try and create multiple accounts, game our voting system, and we'd do that as well. And so we planned for scaling from the beginning, but we now had this new challenge of people would run, and they're in Singapore, and they do this at 2 in the morning, and we'd need to bring up 20 servers in about 15 minutes or as quick as possible. And that actually was a process that went very well for us, using New Relic's API to detect traffic, using Blue Box's API to bring up servers, and using Chef to then configure those servers once they're brought up. You can image your existing servers and scale whatever service you need relatively quickly. And I think that was a service. We wrote a custom Rails app that did this through rake tasks, because that's what we knew how to write. And that was something that works very well, I think, in today's cloud world. And again, with these, what they've said before, what was a challenge for us was the configuration changes and managing the changes and testing that well. So bringing up something that's static that you already know that works, you can copy what you have. Making a change to your Nginx config or to your rescue workers or to where they're going to run or how many are running, and testing that successfully in an environment that replicates production has been a challenge. So, and I think that's really the next step that I'm looking for. I love what's coming out, like in the Chef world, for like Librarian Chef, or there's a new one that I haven't used, Burkshelf. So Burkshelf is like, I love that idea and what that's going to do for managing our cookbooks. And so anyway, there's some great progress being made.
So something that I wanted to actually come back to about your comment about an API for deploying physical servers is that I wanted to kind of drill into what is it that makes people say they want that. And I think that there's a couple things. One of them is the visibility in the amount of time that it will take before you can use that thing. And then the other is the repeatability of the process. And I think that that is the fundamental nugget that is what makes people say, I want an API. And so it doesn't even necessarily have to be a programmable API per se for people to get a lot of value out of it, as much as just something that they can be able to predict and know that I have this much time before I will be able to use this resource. And so that's been, to date, the thing that people like so much about the virtual servers, is that in general, unless you have US East getting overloaded, that you have that capacity that you can assume will be there. And that really is missing right now in the world of deploying physical servers.
That's actually a good point, and that's something that as we're doing this, now that you have that consistency and the amount of kind of steps that you need to go through is so much lower, you can start looking at, what's the turnaround time? What's the deviation? Is it consistent? Is it not consistent? Where are the bottlenecks? Because you're going for shortest spin up time that's consistent as you possibly can. I agree, even if it's not necessarily programmatic, it's more like just turnaround time for delivery that, for me right now, I care about, because even if I'm deploying my own gear, I want that to be deterministic as much as possible.
Well, and I think that an API without those deterministic aspects of it isn't necessarily going to solve the underlying problems that people hope it will.
Yeah.
Does anyone use the Amazon API?
A lot. I mean, not just have ever done it, but like automate it.
Because it's not extremely deterministic.
So
It lacks determinism, unfortunately.
So I guess,
But it's
are there
still
any
awesome.
strategies for kind of mitigating that? Because we do
retries.
live in the cloud, but I mean it's
So, by the way, if you don't understand there's a thing where they have multiple endpoints for the API, and it's abstracted away. You don't know which one you're getting. So you'll say, "Can I have a server?" And you'll say, "Is it done yet? Is it done yet? Is it?" Because callbacks are not heard of apparently to Amazon. So anyway, eventually you hit an endpoint and it says, "Yes, it's done." You go, "That's awesome! High five, Amazon!" And you say, "Awesome! Can you please bind it to that IP address?" And it says, "What server?"
Never heard of it.
And so they abstracted away the ability to sort of say to 3 different endpoints, "Do you all agree, as a team, that server is there? High five, everyone!" That doesn't exist. So yeah. So then you might be able to deal with that if you're doing stuff manually. But when you start automating the creation of stuff on Amazon, your build starts breaking just because shit like that happens. So the determinism, the ability to do it's great. But once you start doing it, the inconsistency starts to want to poke someone in the eye. So here we are in Portland where they have a data center, and I say we'll go down and visit our local Amazon person.
Some of them are here.
Come on up! Hey!
So I guess on that note, wearing sort of the sort of business application developer sort of hats, what do we do, knowing that the cloud's great and we have 100% success every time? Not really.
Automate all the things.
Yeah, we automate all the things, but then what happens when things absolutely go wrong? Because they never go 100% right.
Well, I mean, I don't know. I guess the metaphor is modern airline pilots. They've automated the entire cockpit, except for when shit goes bad. So, if you want to know where your profession goes as a sysadmin, all you get is phone calls. You don't go to work ever. You just start bitching at you every now and again. You go, "Well, I don't know. If the automation doesn't know, I don't know. I'm going back to watching TV." And you crash. No, so, I mean, the aim is just more automation. And the more you automate, the more you hit the edge cases eventually. And you've got to really nail those because they will turn up in production. So,
and for me, what I found is without some kind of visibility into what's going on, whether that's just straight up logging, even if it's not accessible anywhere, or some kind of metrics or graphing, without any visibility into that, you're effectively flying blind. And unless you're ready to manually cope with that, it can be frustrating.
You need to instrument things.
Yeah.
customers will tell you eventually.
So yeah, I guess I'm kind of curious if anybody has anything to add around what do you do to kind of handle that case that this cloud thing, whatever that is, or the application deployment even, it's never perfect 100%.
Well, for us, it's never perfect 100%, so we definitely take strategy. So if we know we need to scale up 2 servers, we'd scale up 6. And then half an hour later, if we got all 6 up, then we'll bring the extra ones down. So because we know that there's going to be times when you bring up servers or when you have bugs in your script that are adding it to monitoring, it doesn't get monitored correctly when something's going to go haywire. So you'd build some redundancy in there. So we've definitely taken that strategy, which I think is applicable to all the hosting providers.
I mean, I think there's a certain amount of what comes through as not trusting the automation at a certain level. You know, like again, taking the airline pilot example, I mean, checklists. You know, checklists are still a great thing. You have to automate everything, but you can't just hit the button and walk away. You know, you still need to know. And, you know, I think this is often a good use for some sort of lightweight smoke test monitoring. So, you know, you want to
You don't want smoke in a plane.
Exactly.
No smoke tests.
So, you know, how can you deploy and then 5 minutes later, you know, sample your infrastructure, is it working, then roll the new ones in. So, I mean, this was something we found very useful with Chef. When we wrote our new version of Chef, we package our smoke tests, our full test suite with the product. So, you know, we already use this internally a lot, so we deploy into our hosted environment and somebody's going to run a fraction or all of the test suite before those nodes are really pulled into production. So, you know, you're automating, but still you're doing that sort of human control. Human has to be in the loop so that you can make a sensible decision.
But you also have a way to kind of help script or automate that, like acceptance. You know,
right,
like
you're running 6,000 tests. You're not doing them by hand, but you're running them.
The natural evolution of everything we're doing is like I said, with planes. It's all going to get too complex for human beings. I mean, think of every sysadmin you've ever known, and what we, you know, I trust the airline pilot. So I just think it's our responsibility to automate all, and you package the smoke tests. Mm-hmm. You automate the testing of it. It's not, you didn't add a human. It's like here's manual Chef. That's not a thing you sell. You don't sell manual Chef, I don't think so. You know, I think it's a constant responsibility, and so the more tools you can use in your tool chain that are a part of everyone else's community, the more you can trust it and live with it. So, you know, the benefit of, you know, some of the things we're talking about, like Chef, etc. You know, is you know, it's just your last bit. But I mean, you've got to assume that it's going to get out of control. We're going to be building bigger and more complex systems. And your ability to manage in your head. I mean, this is one of, I think last Chef Conf, Adam Jacobs was on stage and he was talking about the idea of, you know, the dangerous part of a system is like, when you've got 5 machines, you can kind of give them names, right? You know, and you're nerds, so it's probably going to be a Star Trek theme, Smurfs, something like that. And if you've got 5,000 nodes, then you know you've got to automate that, right? But the dangerous part is when you've got 500, and you kind of think you can do it. I want you to tell you, this whatever job you've got is going to get out of control. You can have lots of machines, lots of apps, lots of services, lots of things to manage, and you can't. So, you know, the responsibility of not just deployment, but running your company, running your team is to automate all the things.
I think there was a quote from this Chef Conf where somebody asked, how many servers do I need before I start automating? Yes.
Yeah, for all values of n. I mean, start now, right? You can have bad automation, and hopefully as your number of things grows, not just nodes or servers, but apps and whatever grows, repos. I mean, you know, yeah, start practicing your automation.
Well, I mean, if we're talking about on the small scale, the number one thing to do before you start automating is document the hell out of everything. That you need to know what it is that you're doing, and once you've done that is the great time to actually be able to understand what it is that you're automating. So, you know, that it is very much a process of understanding what is involved and then removing the human from that for the things that you are doing more than once. You know, for all of the automation that I see, adding the first IP address to a system is often not something that is managed by Chef or Puppet or anything else because, well, you couldn't be running it on it unless you had that part solved. So, you know, there are levels in the automation, and that as you get more things solved, that amount that has to be done by the human is shrunk. But, you know, remember that documentation is the first stage of all that.
Or a very sweet install script.
But isn't that a form of documented?
Absolutely.
You know, documentation.
But you can test a Bootstrap script.
I mean, that's how I started lots of procedures and stuff in previous jobs. I didn't realize I was doing it. Was documenting it, and you break out into these like little, like then you do this and that, and then you're like, I'm repeating this, so I'll make that a variable, and I'll throw it to the top of my wiki.
Yeah, I mean, I'll admit a mistake. I wrote a bunch of documentation around Cloud Foundry and Bosch last year, and I came about to rewriting it, and I thought, no, I'll script it. This will be awesome. But because the project in my head was convert documentation to scripting, it was only after the thing got completely out of control that I thought, yeah, test, that would have been awesome. So one for Matt. Matt's so much cleverer than I am.
Speaking of tests, one of the techniques we use is to actually have integration test suites or acceptance test suites that run against the production system as well as in test. So if you write your Selenium tests correctly, they can drive load to your production system, your staging system, and you can actually verify that behavior is still there. So you can use your test as monitoring. It requires some discipline. We have things that actually send email and check it through Gmail to make sure they get through, but it lets you know that things are actually working. And you don't really care what the infrastructure is doing. Maybe you only got 2 of your 6 servers, but if you're getting the behavior that you want, it doesn't really matter.
Yeah, I mean, if that's a thing you want, there's a company called Still Alive that do that sort of next level pingdom type service of actually not just checking that the endpoint's there, but actually going through real life examples just to determine that your app is not just up, but functioning.
So the general concept of having a canary or multiple of them that are actually going through and confirming that the important aspects of your app are actually up and doing what they should be doing, I think is something that ties very much into these sorts of automated deployment setups when you have a complicated system to do more than just verify that some button worked or something else, or that assuming that you're doing something that isn't just web related, that the other parts of the infrastructure involved are actually doing what they need to.
Yeah. This is the stuff, if you were running like a retail store, you might send in a mystery shopper, right? And they'd make a purchase and they'd check that they got their stuff and they'd feel good about it. Well, to send a mystery shopper in once is to do it once. Put it on TaskRabbit. It's like, can you please go to my shop and buy something and see what happens? It's not just the ideas you were talking about here, I think, are applicable to most systematic enterprises.
I once worked on an API for a large national retailer, and we had our pingdom actually check that there were AA batteries in stock near Richfield, Minnesota. And at one point, there were no batteries in Richfield, Minnesota, and it was a problem. And what had happened was someone had, for the latitude and longitude.
That was the test. It wasn't that you needed it for the failover situation. No, if our system goes down, can we get to the shop to buy AA batteries? That wasn't it.
For latitude and longitude, they'd actually put the area code for the phone number. So it was, 512-512 or something, which meant that they were nowhere near Richfield, Minnesota anymore. And so you want to test actual real-world things and see that your app is actually functioning as you think it is. And at that point, it doesn't matter how it's getting there, as long as it's doing the right thing.
So, and is the strategy that you want to be doing this all the time, on each deploy, once in a while, only when something's non-trivial?
Every 5 minutes.
It depends how expensive the tests are, but
once you have it automated.
You should be running something constantly just to make sure that...
Let's get back to what we're trying to do here. We're trying to keep our production systems running,
right?
So that we can sell stuff or provide the service that we promised. Everything else is, you make choices based on that goal, I guess. Is that the goal? Anyone else want a different goal? So how often do you run your tests? Well, I don't know. If it stops people being able to buy stuff because you're just hammering the crap out of it, sorry, you human can't, shop at the moment. We've got bots busy, destroying it. If you're not making enough money to be able to afford, right? If you just got started yesterday, I don't know about booting up 1,000 VMs just to check your chef code. I guess I'm just saying there's real choices to make, but always be more automated.
So this becomes like your continuous integration for production, like your business CI of sorts.
Yeah, you want to just keep getting a little bit better. And I used to talk about Bosch a lot. I just thought Bosch was the BDs of everything, but nothing is ever. And I came to realize that Bosch is on the continuum of your business getting harder and tougher, and harder and not like me, just buff. Solid. Yeah, like me. So, when you get started, you just want you can do things manually, but you just want to write more features and your business gets more solid. You continue to write more automation to do the things. So don't stop work for 6 months while you automate just because we said so. You got to be awesome in terms of my ego, but nonetheless, invest engineering time. That's the other. That's part of it. There is no other group that's going to do it. There's no magical automation team that they're going to hire, right? It's your responsibility as engineers to do this stuff. This is DevOps. It's got your name in it and everything.
If they do hire that separate team, you should run for the exits.
Yeah, I think that's a really important point. I mean, the best people to know how to automate your system is you. You know, there is no one-button solution. You can't just load a bunch of chef cookbooks or Puppet manifests or whatever, put them on and expect it to run your business. Because your business will have something unique about it. And you guys are the people, you know, who know what that is because you've built it, you're running it already. And so beware of people saying this solution will solve all your business needs. This will automate your system, because it's just not going to happen. You know, pick things that are toolkits, pick things that are technologies that you feel happy extending, building on top of, building things alongside of, and putting it all together for a solution for you.
So I guess it's, you know, a little bit on that note. I'm just wondering how, knowing that these things change over time, like even the low level like architecture, like how do we help manage that change over time when we're swapping out services, changing providers, like changing technology stacks, upgrading databases? How do we help make that somewhat better, assuming like everything's automated, you know, in a nice perfect world, but those are things that can also go very bad, very fast in a very automated situation. Like, I don't know, are there certain situations where you kind of want to like dial that back, or where you put sort of the human back in the decision driver's seat?
You know, I think the key example is there's always things you're not going to do. You know, are you going to let your automated system do a schema upgrade on your live production database with nobody nearby at some random time? Probably not, because you do it so rarely. But bringing in new servers into an auto-scaling system,
Did you test the schema migration already? I mean, did you test the schema migration on a staging environment with the same data?
And with the same, you know, layout of bits on the disk and the same indexes. I mean, I think there are so many variables around there that it can go bad so quickly.
Well, and the same production load makes
a
fundamental impact on that.
You know, I think that can be done. I think one of the engineering groups, or at least their blog that I read, is Etsy, who's been a big proponent of continuous deployment. And I love their mantra is when we hire a new engineer, the first day on the job, they're going to commit to production. And every single commit they do goes through CI, and every single commit pushes out to production. So, and they have a staging environment, and you know, I think it's a new move. I've heard Facebook's VP say as well that every feature that they're going to put on the site has been on the site for 6 months. So, and they have a very robust system that manages which features get rolled out to which users, and they do percentages and test things that way, and you know, really monitor their production stack.
And if this idea is new, I mean, it was just the other day, and since we've got Chef Boy here, Captain Chef Boy. Chef Matt was the
Boy's acceptable.
Chef Boy. And at Chef Conf, Adam Jacobs did a keynote, and I think it does a pretty good high-level discussion of why DevOps and continuous deployment are how all the winners will be doing it. When you look back 20 years from now and look at, you know, what is everyone doing? Well, the people are still in business. The ones that succeed in their industries are the ones that were doing continuous deployment, because it's the only way to give what humans instinctively all want now. And so I won't, you know,
There's not a lot of answers to that question.
in terms of being serviced by providers. So I thought it was an excellent summary. You know, if you're not a chef person, at least go and watch Adam's sort of introduction to the future of all of our industries.
He doesn't mention chef. Perfect chef keynote. He barely mentioned chef.
Right. No. I mean, he's yeah.
So something fundamental
It's
about...
just a great keynote for our industry. So this industry of automation, of not just automation of the low-level stuff, at whatever level you're thinking about, but being able to, as an organization, having the goal of being able to continuously get to the, you know, new things to the customer and better and all the things you want.
So something fundamental that Etsy does that I believe they got from Flickr is the fact that there's no such thing as a big change. And so that's one of the reasons why the automation that they're doing and the continuous deployment works is that they do not have such thing as a feature branch. They don't have any of that sort of stuff. Everything is all conditional in the code, which allows them to make it much smaller, that you always know that there is no massive roll everything back moment where you have to change what code is running.
And it's interesting because I think at some point someone's going to write an actual programming language that has that concept as a first-class feature. In
Like
that
feature flipper kind of.
Well, sorry,
idea,
my point, sorry, is the idea that when do you get to remove that code, right? That idea of, I wrote it, and what's this if statement? Under what circumstances do we ever, for God's sake, get to remove this? And the idea, so it's also the idea of, we look at code as such a static thing. How many of us love to pick the theme or our editor, and we pick an editor and we feel good about it and talk about Ruby. We're all in love with Ruby. God bless the very limited number of people that have come here to talk about running a production system, which is the point of writing a Rails app, right? And so, well, perhaps Ruby's not the best language for running a production system that has that particular feature of permanent, of all the features are in the code.
PHP is far better.
I'm guessing PHP is better.
You've only got one.
Right, but it's an interesting thing to think about, that should the code be providing production features and that come back in your IDE?
I mean, honestly, I think that, the big answer, how do you make a big change, is that you don't. You try to turn every change into as small of a change as you can. Doing any sort of forklift upgrade, be it, moving from one data store to another, changing technology stacks, that if you can do that in a way that you are running the old stack and the new stack side by side and making that change just be changing some configuration setting, and even making that more granular, that you can just start to move traffic over and not do everything, that those are the sorts of things that help to make that not catastrophically bad.
Yep. It's hard because it's not necessarily in the code. You're not looking at this problem in the code. It's like, well, should I make a schema change? You have no idea what that's going to do in production at the time you do it.
So I guess at this point, there's a few minutes left. I'm curious if there's any questions, and I apologize actually for leaving this so late.
Due to the back.
So
Hi, when you guys are talking about auto-scaling your systems, what sort of metrics are you looking at to figure out if you need to scale out? And then how long does that scale take? And then, how do you determine, if we need the resources right away, how fast can we get those resources? And, what sort of metrics are you looking at in order to figure out how many you need or what you need?
So the question was, I guess, about auto-scaling and sort of success criteria, the metrics, what you're sort of looking at for that.
So at King of the Web, we use New Relic's API that monitor our app, and that would give us the primary metrics we looked at was throughput on an absolute level, and then it also gives you an application capacity, which is the number of your Ruby threads that are busy at any given moment. And we actually just used a combination of those, plus we actually monitored, we ended up even monitoring in the end what our most popular people were doing. So if they posted a video on YouTube that contained keywords about King of the Web, we'd scale as well in anticipation.
That's pretty awesome. Bring them on.
So those are the primary things we looked at. And then our scale-up time, we used an imaging solution. So we actually, Chef was used to add the new servers into services like monitoring and things like that. But for just bringing up a new server, we just would use our image of our existing servers, which would take anywhere from 5 to 10 minutes. So you call the API, you bring it up, and then once it comes up, you add it into your load balancers. So there's a small bootstrap script to make sure all the services are running and to start your Rails app and everything. So
one of the distinctions I like to draw is that you can auto-scale down if you want to save money, but you can't auto-scale above load you've previously seen, because you're going to hit things that you haven't seen before. And it's not just about how many servers are running in your application tier. There are going to be other weak points in your infrastructure. So if it's about, I have a bursting load and I know I have a bursting load, yes, sure, go ahead and spend your time figuring out how to save money, but it's always about how to save money. And many people don't actually have that need. Their hosting costs are such a fraction of their engineering costs that it's not worth the time. So really look at your actual load pattern and see what you might be looking at saving before you spend any time on it.
absolutely.
Our auto-scaling solution involves humans. And it's for exactly that reason, that it's not a big enough cost savings to make it worth being fully automated. It is automated such that a human can decide it's time that we need this more and add it.
Yeah, so you talk about sending canaries through the system and making sure they get all the way through the stack. Is that worthy of writing a separate app to do that sort of sending and monitoring, or is that code that's running in production as well as part of like a cron task, such that it all gets bundled and deployed at the same time?
The easiest thing if you're running a Rails app, which presumably you are since you're here, is you can create a separate controller that has one view that pings all your various subsystems. So if you've got Solr or Elasticsearch, you can have it do a search. It can hit your database. It can hit Redis. And it just returns 200. If it can do all these things, it returns 200. You can then sign up for I don't know what Pingdom costs per month, but it's essentially free, and have Pingdom hit that every minute. And Pingdom will then email you or send you some sort of alert if any one of those things isn't actually able to be contacted. And that's the simplest thing you can do to sort of test that all the sort of aspects of your system are working. It doesn't require you running anything. It just exercises all the parts that your Rails app actually exercises. It's not nearly as good as having a full-on monitoring suite that you set up that you're looking at behind the scenes of what your servers are doing, but it'll get you most of the way there pretty easily. You can sit down and do it in an hour or two and test a lot of your application and sort of know that most of the systems are working.
We end up deploying it as part of the Rails app, and then it also will go and connect to a third-party service and hit a URL that if it doesn't get received in an hour, will email us and set off all sorts of alerts that something's obviously wrong.
Cool, maybe one more.
You guys talked about what you did, deploying tons of production, how to make sure that my application integrity is still maintained. What about performance integrity? How do you make sure that I can still do as many hits support as I could before?
So this was, I guess, like deployment and maintaining performance integrity.
It's a good one. I mean,
whatever you're using for monitoring, so, for someone like us, we would use Graphite and be putting all of our things in there and then using some type of change detection, Holt Winters prediction type things to say, let's look at the metric over time, and I've now got an event, let's look at what happened afterwards, and something that's going to flag on that.
A lot of metric systems now let you tag things, shit that happened.
Yeah.
Like I deployed, I scaled, or whatever, so it'd be interesting to put that in there and at least figure out what might have caused the thing, which then gets you to who did it, and then you can use the old fisticuffs to.
Yeah, I still think the best metrics correlation metrics correlation system is still eyeballs. So having something where you can plot events at discrete time points, like your builds, your deploys, whatever, and then look at what happened. Yeah.
For all my airline pilot metaphors, obviously the distinction is flying a plane from San Francisco to New York looks the same within a pretty good standard deviation most times, whereas each of us run very different systems that the systems themselves change over time. So yeah, there's obviously, you want to automate as much as possible, but it's a little bit of a dream to think that you can get rid of the humans.
And you should definitely be alerting on the worst case scenarios that you're starting to see queue depths in your HTTP request handlers and things like that, that things have gone bad if you've gone past the threshold of what your system can handle, if everything is terrible.
If you have graphs of your key metrics and you look at them after some sort of catastrophic event, if you've been looking at them every day for the past month, you will know that something's wrong.
Well, I'm not talking about in terms of catastrophic failures. We're talking about this little, using a lot of little changes at times. Like that little change caused a performance degradation. And if you're always deploying small bits of little code and you're having trends that are larger, it's going to be hard. It's not just like crap, everything's perfect on it. It's like
Sure.
Like we switched from Rails 2.3 to Rails 3, and look, it got slower.
That's what it does.
I wonder what that could possibly be.
Tell anyone.
But yeah, I definitely think that's where you definitely want to know if you do have some kind of a graphing or some solution where you can correlate the deployment event of that change set with sort of the performance, like your request time or something. So you can sort of see as of Monday, it was all right. But like yesterday, something really like went weird, and hopefully be able to try and track that back. But this is where I guess having like the ability to spin up a production-like environment that can have similar performance characteristics really helps to test those regressions, I guess.
We also will write performance specs if we have a performance degradation that we notice and have to go in and fix. And so you can actually oftentimes write a spec that says this thing happens in this amount of time. And we'll often put a multiplier in there that we can set on a given machine. So if you're running on a Mac Mini that's your CI box, you set your multiplier up to 4. If you're running on your iMac, it's a modern new thing, you set it to 1. But most of the time, a given thing should finish in that amount of time. And this will work if you have sort of areas in your code where you really do have n-squared problems, where people that don't know what they're looking at can sort of say, oh, I can fix this. And I've done this before myself. I could do this way cleaner. Like, I'll just use Ruby's set class, and it'll just do a set difference, and it'll be beautiful. And it was beautiful, but it was extremely slow.
It was okay for 5 example items.
But unfortunately, the data set had about 1 million items in it. And it worked fine in tests, but if you then write a performance spec with enough elements in it, it was very easy to pull that back out and say, okay, that's not going to happen again. But it is just something you have to watch and deal with as a developer.
I'd like to see more of things like Heroku, Cloud Foundry, and other deployment, chef recipes, or however people are doing deployment of things, apps or whatever, to be allowed to do more A/B testing. That's not the right word. You're not sort of testing for the ability to introduce things gradually. A bit like the feature flag idea, but can you introduce some code? So let's just let some traffic flow through it, and then incrementally more. And I think you play with this idea in and around Cloud Foundry. I'd like to see that as a feature that all these systems have. So it wasn't like well, yeah, we should do that, but then we'd have to give up Heroku and build it. And no one wants to do that. So we'd like to see those sorts of things so we could behave in this fashion so we wouldn't have over terrible, terrible things happening. You can see that's
the all or nothing deploy.
Yeah, which is what we all do.
So I think it looks like we're totally over on our time, so I apologize for that. We may as well wrap it up.
I think you got tremendous value, and you're lucky that we decided to spend a little extra time talking to you.
So yeah, if anybody's interested in talking more, you can find anybody here if you see them. Blue Box has a booth down in the pavilion where you eat. I'm not sure what that's called.
Tomorrow.
And I'm sure there'll be lots of people around there who are interested in this as much as I am. So thank you guys very much. And thank you to all the panel.